The displacement current. A dielectric of permittivity epsilon equals 3.5 10 to minus 11 farads per meter completely fills the volume between two capacitor plates. For t greater than 0, the electric flux through the dielectric is phi sub e as a function of time 8.010 to 3 volts meters divided by second cube t cube. The dielectric is ideal and non-magnetic. The conduction current in the dielectric is 0. At what time does the displacement current ID in the dielectric equal 21 microamps? Okay, so we are given the electric flux phi sub e to be 8 times 10 to 3 t cube. Now we have the closed path integral b dot dl equals mu 0 times current enclosed, that's Ampere's law. Now Maxwell added another term to this, which is plus mu 0 times the displacement current, I sub d, and the displacement current is the permittivity epsilon d phi e dt. So normally this is mu 0 epsilon 0 d phi e dt, but if it's in a material with permittivity, relative permittivity epsilon r, then it would be epsilon r epsilon 0. So that's the displacement current. Now if I look at the displacement current at a certain time, the permittivity is given to be 3.5 times 10 to minus 11 farads per meter. Now I have to take the derivative of the flux with respect to time. The derivative of t cube is 3t squared. So that's plus multiplied by 3t squared, 8 times 10 to 3. And this gives us the displacement current as a function of time, 8.4 times 10 to minus 7 t squared. So if I evaluate it at a certain time, this will give me 21 microamps. So this is equal to 21 times 10 to minus 6 amps. And from this equation, I can solve for t, 21 10 to minus 6 divided by 8.4 10 to minus 7 square root. And the answer I obtain is t is equal to 5.0 seconds. So at t is equal to 5 seconds, this is the displacement current, 21 microamps. So basically, I was given a dielectric of a permittivity that fills the space between the plates of a capacitor. The electric flux as a function of time is given. The modified Ampere's law, closed path integral b dot dl equals mu 0 I enclosed, has this additional term, mu 0 displacement current. In free space, this is mu 0 epsilon 0 d phi e dt, but in the material, this is epsilon d phi e dt. And I need to take the derivative of the flux with respect to time, which gives me 3t squared times 8 10 to 3, multiplied by epsilon is the displacement current. And this, when is this equal to 21 10 to minus 6 amps, 21 microamps? That's when t is equal to 5 seconds.